All right, this is my lecture on mole conversions to go along with the Nearpod notes that you filled out already. In this lecture, we're going to talk about what a mole is and how it's related to other things and how you convert between those other units and a mole. So to start with, before we get to moles, a lot of times you'll see where you'll use a larger unit to count objects. And the purpose of this is to make them easier to count. So example is to count eggs, we say we have 12 eggs in 1 dozen. Okay, and so we can count dozens of eggs versus individual eggs, and it makes it easier to count. The same thing goes for paper. Like a pack of printer paper is called a ream. So you can say you have, 3 reams of paper or 3 packs of paper versus counting the individual pages. So these are known as counting units. And again, the purpose is to help count large amounts of objects. Well, chemistry is an area that has large amounts of objects. We have a lot of particles. And so chemistry has developed its own counting unit known as the mole. Okay, and so the mole here is not the little furry guy. Instead, it's a quantity or an amount of a certain substance, and it's a specific amount of particles. And it's a certain number of atoms that is exactly found in 12 grams of carbon. And they use carbon for this because it's the most abundant molecule on Earth. All right, and so what is that exact number? That exact number is known as Avogadro's number, not avocado, Avogadro's number. And that the actual numerical value is 6.02 times 10 to the 23rd. Okay, this is an insane amount of atoms. And essentially what this allows us to do is say, okay, this many atoms is equal to 1 mole. And then we can count those atoms or particles or any whatever term you want to use a lot more effectively. And so what we're saying here with this, the relationship we're saying and the importance of this is that 1 mole, right here, 1 mole is equal to 6.02 times 10 to the 23rd particles. Now, particles is a general term, okay? So particles can be atoms, molecules, something known as a formula unit. This is an older term for a particle, protons, electrons, ions. Basically, particles, anything, any word you can use to describe something in an atom or a molecule or something like that. Okay, so this is what a mole is. A mole is this specific amount of particles. Well, also in chemistry, we have talked about mass. And in Unit 3 last semester, we talked about an atomic mass, how you calculate that, where you add up all of the, you take like the percentage times the mass and you add them all up. And if you look on the periodic table, so let's take carbon for instance. So we have our box with carbon in it. So you'll have your C. Remember, 12 is the atomic number. And at the bottom, you have 12.01. This here is your atomic number. Excuse me, atomic mass. So the mass that's at the bottom of the periodic table. Okay, so the atomic mass is the mass of that actual atom. Well, when we start combining things together, we need to calculate a new mass. Okay, and so that term is called molar mass or formula weight. So molar mass is basically the mass of a compound. Okay, and so again, it's also known as formula weight. That's another term. It's typically older. And the way we do this, I'll talk about how to do it in a second, but the units for this, which is really important, and we'll come back to this in a minute, is grams per mole. Okay, so it's saying that it's, 15 grams is equal to 1 mole. Okay, so this is your relationship between mass in moles, and again, we will come back to this. But the way you basically do this, and I'm going to do an example in a minute, is you are going to take the mass of each atom, or each element. So if we have, element A, we have 3 of those, and we have element B, and we have 2 of those, okay? So what I'm going to do is I'm going to do 3 times the mass of A, and I'm going to add that to 2 times the mass of B, okay? And so basically, what I'm doing here is I'm taking how many of an atom I have times its mass, and then I'm adding that to how many of the other atom and what its mass is. So it's a common accumulation of all of the masses of all the atoms or elements within a compound. Okay, so here's an example. So it says calculate the molar mass of ammonium, which is an H3. Okay, so I'm going to multiply the mass of each element by how many are in each are in the formula, and then I'm going to add up all the masses. Okay, so when it comes down to it, if you want steps, basically step 1 is to multiply the mass of each element by how many you have. So 2, 3, 1, and then step 2 is to add them all up. Okay, so here we have 1 nitrogen atom, and the mass of nitrogen is 14.01. So it gives us a total of 14.01. We have 3 hydrogen atoms, and each hydrogen is 1.01. So that gives us 3.03. So when we add those together, which is the second step, the total mass of ammonia is 17.04. So when we're looking at what the total mass of ammonia is in H3, it's 17.04. Now, when you're doing this, I round to 2 decimal places. You can round to 1. Try not just to use whole numbers. So don't just say 14 plus 3. While that is easier, it's not as precise or accurate. So try to go out to 1 decimal place at least. Okay. So here's another example. A lot of with this, there's a bunch of examples, but I'm going to go through this one fairly quickly. With this one, we have KC2H3O2. Okay, so again, we're going to take how many we have of each one times the mass of that element. So 1 potassium, the potassium's mass is 39.1. 2 carbons, carbon is 12.01. 3 hydrogens, you have 1.01 as its mass, and then 2 oxygens, and oxygen is 16. Okay, so once we do that, we get all these values, okay, and then we're going to add those up, and when you get that, you get a mass for this compound of 98.15. Okay, so we take how many we have of each, multiply by the mass of that element, and then add everything together. Okay, the other way to do this, so for like this one, if you want an alternative way, and this will probably be how I do it from time to time in class, is we can kind of do them in 1 step. Okay, so if 2 steps is clear for you, great, stick with that. If you want a quicker way to do this, we can literally just say 39.1 plus 2 times 12.01 plus 3 times 1.01 plus 2 times 16. So I can go through and I can do this all in 1 step. And the only reason why I didn't put a 1 in front of the 39.1 is because 1 times 39.1 is 39.1. And so when I do all that, if I just plug all that in my calculator, I get 98.15. Okay. And so that's another way to do it and get the same result. So either way is valid. You can do them you can do the first step by so you can come up here and like I did here, you can do all of this as step 1 and then this as step 2, or you can do it all in 1 step where I did down here. Okay. All right. So remember when we talked about in Unit 1 how to convert between units. We use something known as, and I know y'all loved doing this, dimensional analysis. Now, dimensional analysis just is this setup here where you have the units that you're given and the units that you want, and you basically set up this fraction. Okay, so an example that we did was we said convert 2.5 gallons of milk, so that's our given, okay, to liters of milk. Okay, that's what we want. Okay, and so we would set up our fraction, and they tell us the conversion. 1 liter equals 0.264 gallons. In this case, we are dividing. So 2.4 divided by 0.264. Okay, and that will give you 9.47. Because remember, if it's on the bottom, you divide. Okay, if it was on top here, like where the 1 liter is, you would multiply. Okay, we can use this same system to convert between different things, convert in terms of moles. Okay, and so that's what we're going to spend the rest of the units, the rest of this lecture talking about, is how do we relate moles to things like how many particles there are and how many, and then what the mass is. Okay, and so when it comes down to it, moles, based on this definition, is related to how many particles are in a substance. But we can also relate it to the mass using the molar mass. Okay, so the big thing to remember is there are two things we're going to deal with. We are going to deal with Avogadro's number. Okay, that's 6 times 10 to the 23rd, or 6.02 times 10 to the 23rd, and we're going to deal with the molar mass. Okay, those are the two numbers we're going to deal with. Okay, nothing else. It's not like when we did dimensional analysis where you had a whole list of different, 1 kilometer equal this many meters and, centimeters and all this stuff. It's only these two units. Okay, and this down here, okay, this little graphic, I will give this to you, but this basically tells you, without using fractions, how do you go about going between things. Okay, so if I wanted to go between particles and moles, I would divide. So that's what's happening here. I would divide by Avogadro's number. If I want to go the other way, I would multiply. Okay, and then with mass, if I want to go from moles to mass, I would multiply by either the atomic mass or the molar mass, just depending on if it's an element or a compound. And if I'm going the other way from mass to moles, I would divide. Okay, so I'm going to set it up with fractions, but when it comes down to it, you can just multiply or divide. You don't have to worry about the fractions. You just need to make sure you can tell what you're starting with and what you're ending with. Okay, so let's do the first one. Okay, the first one is going to be moles to particles. Okay, so going from a certain amount of moles into particles, or a certain number of particles into moles. And we're only using Avogadro's number here. Okay, we're only using Avogadro's number. Okay, so here's your shortcut. This is something I would star, I would highlight. This is going to be what you want to come back to. Okay, so if you're going from moles, where you start with moles, and the question asks for the number of particles, you will multiply by Avogadro's number. Whatever value they give you, you multiply by that number. The opposite, if they give you a number of particles and they ask for moles, you will divide by Avogadro's number. Okay, and those are the only two situations you will have. Either the number of moles to particles or the number of particles to moles. Okay, this is where we're going to start with, and then we're going to build on that. So, the other thing I've included here is the triangle. Okay, if you don't remember how to use this, when I get back, I can explain to you on person, but if this is a better representation of how to work these problems, please use this by all means, and I will provide this on quizzes and tests along with that graphic from the previous slide. Okay, so examples. So with this, I'm going to try to point out how do I know what they give me and what they're looking for, because that is something that a lot of people have an issue with and are confused by. Okay, so first of all, my first question, how many molecules are in 15.7 moles of carbon dioxide? All right, so they give me a number and a unit. So this is my starting point, what I'm boxing here, 15.7 moles. So I know I am starting with moles, okay? And then they ask, how many molecules? Well, then molecules is a type of particle. So in this case, I am given moles, and I want the number of particles. So if we go back to my previous slide, I said my first bullet point here was, I'm going to multiply by Avogadro's number. Okay, so I'm going to take 15.7 multiply by Avogadro's number, 6.02 times 10 to the 23rd. Now, when you do this in the calculator, remember you have to use parentheses. If you do not use parentheses, you will not get the right answer. Okay, and then when I get my answer, I'm going to get 9.45 times 10 to the 24th. So all I'm doing is taking 15.7 and multiplying by this Avogadro number, because I'm going from moles into molecules, which is particles. All right, so that's one example. Another example, it says calculate the number of moles in a sample of sodium bromide that contains 2.88 times 10 to the 23rd formula units. All right, again, they tell me my number is 2.88 times 10 to the 23rd formula units. Okay, and so that is what I am starting with, because that's the number they gave me. Okay, so let me make my box a little bit better. Okay, my moles here, okay, is what I'm looking for. So I'm starting with particles and I'm going to moles. So if I go back here, that second bullet point told me I needed to divide by Avogadro's number. So that's what exactly I'm going to do. I'm going to take 2.88 times 10 to the 23rd, and I'm going to divide, because remember, if it's on the bottom of this fraction, then I'm dividing. Okay, so I'm going to take 2.88 times 10 to the 23rd. I'm going to put that in parentheses. I'm going to divide that by 6.02 times 10 to the 23rd, also in parentheses. Okay, and when I do that, I get 0.48. All right, so the questions are not meant to be tricky. I'm looking for one thing, and I'm given one thing, and I'm looking for another. So look for the number they give you, pay attention to the units that are with that number, and then look for what they're asking for. Okay, so mole to particles is going to be the first thing we do back when I get back on Monday, and then we're going to focus just on that. Okay, then we're going to move on to the next thing I'm about to talk about, and then the third thing is going to be the two combined. Okay, so we're going to take this stepwise, so if you're really confused right now, try your best to understand it, and when I get back, we're going to focus just on this. All right, so that was moles to particles. Now what we're going to do is we are going to look at moles to mass. And when we look at moles to mass, we have really two different things we can look at. We can look at where we're going from moles to the mass of an element, okay, where just it's one thing, or we can go from moles to the mass of a compound. So I'm going to talk first about the mass of an element. The process for both is exactly the same. It's just depending on whether you just use the atomic mass off the periodic table or you have to calculate the molar mass first. All right, so similarly to the previous one, we are just using the atomic mass of the element. We're not using Avogadro's number in this case. We're just using the atomic mass. And I've made a shortcut thing for you again, okay? So if you're going from moles to mass, you multiply by the atomic number. If you're going the opposite direction, mass to moles, you're going to divide by that number. Okay, now this is slightly different than the one I just talked about because of the fact that the mass will change based on what you have. With particles and moles, it doesn't matter what you have, it's just the number, because Avogadro's number is the same for everything. With mass, it is specific to the element or the compound. So you need to make sure you use either the atomic mass on the periodic table or the mass on the of the compound. Okay, so let's look at some examples. All right, again, here's the triangle, similar to what I did before. Again, if this doesn't make sense to you, don't worry about it. If this makes more sense, then use this, please. I will provide both triangles and the little schematic on all quizzes, tests, all that stuff. Okay, so again, I'm going to go through and point out what they give us and what we're looking for. Okay, so calculate the mass of 0.625 moles of calcium. All right, so 0.625 moles. So I'm given moles and I'm given a number. Okay, they want mass. And then my other clue is calcium. I have to pay attention to what it is. So I'm going to multiply, because that first bullet point here says if I'm going from moles to mass, I multiply. All right. And then the other thing I got to do, which is a little different than the other questions we just did, was I have to look at the atomic mass. Okay. So I go and I'm going to look on the periodic table and I'm going to look up, and the atomic mass is 40.08. All right. So then I'm going to go in, I'm going to take my 0.625, multiply it by 40.08, and my answer is going to be 25.1. And that's it. I take my amount they gave me, multiply by the mass I looked up, and I'm done. Okay? The other question. Let's go the other direction. So a roll of copper wire. So copper, that's my element. So I got to pay attention to that. Has a mass of 848 grams. Okay, so that's what they're giving me. They're giving me an amount, and I'm giving grams. In this case, they want to know how many moles of copper in the roll. So if I go back to my shortcut, the second bullet point here is going to be where it says to divide, because I'm going from the mass, which is grams, to moles. Okay, and that's one thing that I want to make sure I mentioned. Mass is always measured in grams, so if it doesn't specifically say mass, if you just are given grams, then that you need to clue in that that is talking about mass. Okay, so that may be something you want to jot down on your sheet. Okay, so I'm going to divide. Again, I've got to go look up the mass of copper. So copper is Cu, and when I look it up, it's 63.55. Okay, so I'm going to take 848. Okay, so 848 and divide it by 63.55. Okay, and when I do that, I get 13.3. So again, we're not using Avogadro's number, we're using the mass, so I have to look up the mass each time, but it's the similar process. Go from one to the other, I multiply. If I go from the other to the other, I divide. So you have to pay attention to what you're given. All right, so the only difference between what I'm just talking about and what I'm going to do now, I'm kind of going to breeze over this because it's basically the same idea, is that instead of an element, I'm dealing with a compound. Okay, so with a compound, you got to go through and you've got to add up all those masses. You've got to find the molar mass. Okay, so the same thing applies as before. You use the molar mass to when you go from moles to mass. You actually, this should say, and I will correct this in the, I will correct this in the Nearpod. I should actually say multiply, and this should say divide. I got these mixed up. Okay. So when you go from moles to mass, you multiply. When you go from mass to moles, you will divide. Okay. So I will correct that in the Nearpod that you copied. All right. So let's look at some quick examples. I'm not going to go through this in all its gory detail because this is exactly what we just did. Okay. So determine the mass of 0.187 moles of tin 2 sulfide, and the formula is given to you. All right. So we are given 0.187 moles, okay, and we are given we want the mass, and our compound this time is SnSO4, okay. So when they tell me here, that first one, I'm going to multiply. All right, but the first thing I got to do is I got to find the molar mass. So I look up the mass of tin, I look up the mass of sulfur. Okay, so this is tin here, this is sulfur, and this is oxygen. And I have 4 oxygen, so I'm going to multiply by 4. And so that gives me a mass of 214.78. Okay, so then I take my original number, 0.187, times 214.78, and that gives me an answer of 40.2. Okay, same thing we just talked about. We're going from mass to moles to mass, so we're going to multiply. Now, if we are given the mass, Okay, so in this case, how many moles are in 1,000 grams of water? So here's my mass, which is 1,000 grams. They want moles, and water is my compound. Okay, so hopefully everybody knows that water is H2O. Okay, so when I go back here, mass to moles, I'm going to divide. Okay, so that's second bullet point here. Okay, so again, I got to find my molar mass. So I take 2 times the mass of hydrogen, which is 1.01, add oxygen here, and I get 18.02. So I'm going to take 1,000 grams and divide it by the molar mass, which is 18.02, to get an insane amount of moles, which is 55.5. Okay, so the only thing with moles to mass is it depends on whether it's the compound or an element. If it's an element, you just use the periodic table mass. If it's a compound, you got to find the molar mass first. Okay. Now, this is going to be the hard part. Okay, and I will re-explain this when I get back because I know this is probably about to blow your minds. But if we combine the two together, you can go from the amount of particles to the mass or the mass to the number of particles. And it will involve 2 calculations, okay? I'm going to show it in one step, but you do 2 different calculations, okay? And in this case, you use both Avogadro's number and the mass of either the element or a compound, okay? And so again, you have to do 2 calculations. So you're going to multiply and then divide. All right, so here's your cheat sheet. Again, cross this out, we're going to go from, the far left of the diagram all the way to the right and back and forth. Okay, so if we have the number of particles to mass, you're going to divide by Avogadro's number and then multiply by the mass of the element or compound. Okay, so you remember the molar mass. Okay, if you have mass to start with and you go to the number of particles, you are going to divide by the mass, and then you are going to multiply by Avogadro's number. Okay, so let's do 2 examples, and then we're going to wrap this up because I think at this point I'm starting to hurt your head. Okay, so calculate the number of atoms in 4.77 grams of lead. All right, so they give me 4.77 grams, so that's mass. They want the number of atoms, that's particles. And again, I have to pay attention to what I have. Lead, that is Pb on the periodic table. So I'll go and I look up the atomic mass, which is 207.2. And here's where my math comes in. My first step is, because I am going from mass to atoms, okay, we said that we are going to, it's going to be the bottom one here. We're going to divide by the mass and then multiply by Avogadro's number. So this first bracket here, I'm going to take 4.77 divided by 207.2. Okay, and then I get some answer. And then I'm going to take that answer and I'm going to multiply by 6.02 times 10 to the 23rd. Again, in parentheses. You have to put this in parentheses. And when I get done, I end up with 1.39 times 10 to the 22nd. Okay? So, I take my mass divided by my molar mass, like the mass they started with, 4.77 divided by the atomic mass, then multiply by Avogadro's number. So it's 2 different calculations. I can do it all in my calculator, but I'm going from one to the other. Okay, let's do the other direction. What is the mass of 3.13 times 10 to the 21st atoms of potassium bromide, KBr? Okay, so they give me 3.13 times 10 to the 21st atoms. Okay, they tell me that it's KBr and that I want the mass. Okay, so I am going to go with this first bullet point here. I'm going to divide first by Avogadro's number, and then I'm going to multiply by the mass because I'm going from the number of particles, which is atoms, to the mass. Okay, so before I do that, or second-wise, I kind of do it first. I'm going to find the molar mass. So I take the mass of potassium, which is 39.1, plus the mass of bromine, which is 79.9, and I get an answer of 119. Okay, so here's where I'm going to do my two calculations. First, I'm going to do 3.13 times 10 to the 21st in parentheses divided by 6.02 times 10 to the 23rd in parentheses. Okay, so again, I'm going to get some answer. Then I'm going to multiply by the molar mass, which is 119. And when I do, I get my answer of 0.62 grams. Okay, so yes, while this is complicated, and I know it's probably very confusing, I will come back and I will walk you through more examples of this. This is kind of the hardest of them, and we won't do this till the end of next week. All right, so to summarize, you are either going to use Avogadro's number or the mass, okay? You need to pay attention. This is how you answer the questions. Pay attention to what they give you and what they want. So circle it, underline it like I've been doing it. However you want to visually see it, write it out. That is going to help you with a lot of these word problems because almost all of these are word problems. All right, so hopefully this will explain the notes you took. Again, I will be back on Monday. I will re-explain this again. On Monday, we are going to focus just on the first part, the particles to moles. So I wanted to give everything to you, and then we're going to do this section-wise. So we're not going to try to do all this at once. Hopefully this has helped. Make sure you do your work that I've left you because it will be a grade.